Hello everyone, we're Team 4. The project we did is called ExploreKU, which allows you to explore KU campus through your smartphone cameras. ExploreKU is a mobile application that uses augmented reality to enhance map navigation to KU campus. We as a team considered to do this project is because we all like AR technology, and especially for location-based application like Pokemon Go. And we felt other apps such as Google Maps is not that convenient to use because they have either outdated data or leaked information such as building history, coming bus schedules, and parking lot hours. So how ExploreKU works? Well, the location server implemented with Ruby on Rails, and the AR mobile application implemented with Unity. I'm going to first introduce the location server, which is the management dashboard. This is the dashboard interface. There are basically three functions: admin users, locations, and roles. So if I click on the admin users here, then it will show all the administrator user informations, and it shows by emails and the current sign times. I can view it, edit it, and delete it by clicking on those buttons. If I want to add a new administrator user account, then I can click on this button. To click on the location button here, it will show all the location informations. It can be sorted by IDs or by the names. It includes the latitude, longitude, altitude, and location types. I can view it, edit it, and delete it by clicking on those buttons. If I want to add new locations, I can click on this button here, and it allows me to add the new informations. And the new location can be divided into building types, parking lot types, and bus stop types. Click on the rows button here. It will show all the rows informations. It also can be sorted by the IDs and by the numbers. If I want to add new rows, I can click on this button here, and it's the same as adding a new locations. There's a filter on the right for each of the function. This filter allows me to search specific objects. For example, if I want to search all the buildings, I can choose the buildings here and filter it. Then it will show all the building information for me.
When we develop our application, we understand that deploying new application and importing new data can be quite a hassle, so we want to make it as easy as possible for the administrators to do them. The first time the application is deployed, administrators first can call rake dbmigrate. This will apply all the database migration until the latest modification specified inside dbmigrate. As we can see here, there are files that correspond to each specific modification to the database, such as create location stable, create building stable, and many more. It is a good practice to do every modification to the database structures through these migration files. So, whenever the administrators want to deploy the application in a new machine and have the latest structure and version of the database, they can just call rake dbmigrate later on. After we apply all changes to the database to get the latest database version, we call rake dbseed. This will populate the database with initial data that needs to be in the application when it first deployed, such as the account information of the administrators. Otherwise, we will not be able to log into the administrator panel as there is no account information yet in the database. The initial data is specified inside seeds.rb file. These two steps are the steps that need to be done when deploying the application to a new machine. Along with time, the administrators may want to add, delete, or modify data in the database. It is often the case that administrators want to input not only one data at a time, but hundreds of them. To facilitate this, we have import function. There are 6 types of data that can be imported, namely building, bus stop, parking lot, route interval, and route stop. Each of these types will have specified structures to correspond to the database structure. All the administrators need to do is replace these files with the new files containing the data they want to import and then call rake dbimport. Then the application will import the data inside all these files. This way the administrators do not have to input data manually one by one. These are the functionalities we offer to solve the problem of deploying the application in a new machine and importing data to the database.
The last component of our server is the APIs. We use 2 RESTful APIs to communicate between the front end and the back end. The proximity search API takes in a location's coordinates and a search radius in miles from a request. It then responds with a list of locations whose distance to the input is smaller than or equal to the search radius. We allow additional parameters to further customize the output. We use sort by to sort the result by a location attribute. We use count to limit the number of results. We use type to filter the results by location type. We use keyword to only keep the results whose names contain that keyword. For example, this API call returns all buildings within 0.1 miles from Eaton Hall. The results are sorted by their relative distance to Eaton Hall. The location show API takes in a location's ID from the request and returns detailed information about that location. The response varies based on location type. Currently, we have 3 types: building, parking lot, and bus stop. This API call shows the information about the bus stop in front of the engineering buildings. Apart from its name, number, and coordinates, we see the arrival times of buses that stop there. This API call shows the information about Eaton Hall. Here, we can see a link to the building's image, description, address, the amenities it has, and the departments it belongs to.
Thanks for the hard work by our backend team. With the power of the backend, we are able to show ExploreKU in the form of augmented reality. Shortly after launching the app gets the phone's location and sends a query to the backend. As soon as the backend returns, the location in the near distance are being rendered as interactive labels. In the capture scene, we can see 3 different types of labels: building, parking lot, and bus stop. The red icon represents building, and the blue icons with the P represents parking lot. Then we turn to the other side with the phone and we have the bus stop icons. Tap on the Learned Hall icon to see the building panel. At the top is a thumbnail image. Under the picture, there are detailed information about amenities and departments inside Learned Hall. If we keep going down, it will show us a brief history of this historical building. Now we turn to Jayhawk Towers and see the parking lot panel. In the panel, we have a list of available parking spaces. As for this parking lot, it is a JT permit only parking lot. There are 87 spots for Jayhawk Tower residents and 4 handicap spots for accessibility. The bold text describes the regulations of this parking lot. There are 2 more examples, one for West Learned parking lot and another for Eaton Hall. We will show you the bus stop panel with bus stop 15 and Green Street. In the panel, we provide a list of next arrival times of buses that stop here. On the left are the route names and the corresponding arrival times for each route on the right. We integrate the messaging inquiry functions from Lawrence Transit into our bus stop panel. When we click on the Check Next Buses button, the panel will switch to the built-in message program, and an inquiry message is composed. After sending this inquiry message, we'll receive the response from Lawrence Transit. There are also extended lists of arrival times for each route. Tap on the list cell to see it and use the button to compose inquiry for individual route. Using the search API provided by the backend team, we represent a filtered list of locations. User can choose from 3 different types of locations and see a list of locations of that type. Tapping on the cell will also lead you to the different info panels we have shown you before. You can also type in keywords on the search bar to filter through the list for more detailed location info. Our app can also be deployed onto other mobile platforms supported by Unity 3D, as long as the device has support of location service, magnetometer, and gyroscope. Here is our app running on an iPhone SE while we were at the Wesco Beach.
For future version, it can integrate the database with KU system. We can also add a routing function in the app. We also think this type of app can extend it to Explore Lawrence, Explore Kansas, or even explore America. Thanks for watching.